Hello, everyone. Welcome to another Rayco Rents webinar. My name is Tony Jolly. I'm a rental associate here at Rayco Rents. Before we get started, I just want to thank everyone who stopped by our booth at the AIHA conference in Columbus 2 weeks ago. It was really nice to be able to reconnect and meet some of you all for the first time. WaveControl also had a booth there, so it was nice to meet their team, and it's always nice to be able to have a good relationship with the manufacturer of the equipment that we own here. But anyway, today's presenter, we have John Alpha of WaveControl, and he's going to dive into EMF monitoring, specifically using the SMP3 EMF monitor. Today, he's going to cover the potential health impacts of electromagnetic fields. He'll explore the functionalities and sampling techniques using the SMP3. And he's also going to cover industry standards as well as emerging trends. John is an application engineer at WaveControl. He's currently responsible for new application and product development of RF safety devices. He is also involved in product demonstrations, global training, and application notes. And he's currently an active member of the International Electrotechnical Commission. Since we have a large number of attendees, everyone will be muted. We do have a chat box that you can use to ask questions or leave comments at any time. And after the presentation, if we have enough time, we'll try to go over all the questions that we can. About 1 or 2 hours after the webinar today, you'll receive a certificate of attendance along with a recording of the webinar. If you don't receive either one of these, feel free to contact us and we can send that to you. Also, just keep in mind our webinars are always posted on our website. You can find all of them in the Training Center tab, so you can view those at any time. For now, I'm going to turn over the mic to John and let him take the lead. Welcome, John.
All right, thank you very much, Tony. So thank you all for being a part of this special webinar session on EMF measuring techniques. So I'm John Alpha from WaveControl, and today's webinar, I would like to address EMF measurements in different applications using the SMP portable meter to comply with standard requirements. So before we start, just a little introduction to WaveControl. So WaveControl is a company located in Barcelona with 27 years of experience in EMF safety, providing numerous solutions. Now let's go to the introduction of electromagnetic fields. So just a short introduction to electromagnetic fields, and then afterwards we're going to take a look at some applications and then some standards. So for the basics on electromagnetic fields, so electromagnetic waves are synchronized oscillations of electric and magnetic fields, which in vacuum travel at the speed of light, and they're usually associated with the use of electric power and various other forms of natural or artificial lighting. So typically they are described by their frequency, wavelength, or photon energy. And also you have the relationship between the first two properties, frequency and wavelength, given by the formula which you have here, which is frequency is equal to the speed of light divided by the wavelength. Then there's a direct relationship between electric and magnetic field when you are in the far field condition. So when you say far field condition, you're referring to the distance when you're far away from the source, when this source, the EMF source, is radiating. So this is the point where you measure in far field. So for far field conditions, electric and magnetic field has a direct relationship. So you only need to measure one of them. So for example, measuring electric field, and then you can estimate the magnetic field using the impedance or free space. So we're going to take a look also at the SMP meter, which has different probes, which allow you to do electric field measurements and magnetic field measurements, for example, in near field regions, but also in far field regions, the electric field probes, which go up to 90 gigahertz, can do the measurements for electric field and also estimate the value for the magnetic field using this formula here. So for electromagnetic field assessments, when we talk about non-ionizing radiation in terms of electromagnetic spectrum, so there are two main interaction mechanisms which electromagnetic field interacts with the human body. The first mechanism is when you are exposed to electromagnetic fields between the range of 1 Hz to 10 megahertz, where stimulation of the nerves and the muscles occur. So these effects could be indirect, direct, or also transient effects, and they're referred to electrostimulation effects. So these are the effects that affect the nerve and the muscle. So they create some kind of stimulation of these different parts of the body, but also particularly sensory organs. Then you have the second interaction mechanism, which is the heating of body tissues. So this is from the range of 100 kilohertz to 300 gigahertz, where there are thermal effects which happens in different parts of the body or different tissues of the body depending on the frequency and the intensity of the field. So this is the range where you need to perform assessments using the time average method. So let's take a look at some of these different frequency ranges and also the different biological effects which can be experienced in these different frequency ranges. In EMF assessment, these fields are usually divided into static fields, so going at 0 hertz, low frequency fields going from 1 hertz to 10 megahertz, and then also high or radio frequency fields which go from 100 kilohertz to 300 gigahertz. So for the case of static fields at 0 hertz affect the body in 3 different ways. The first is direct effects, such as induction of electrical flow potentials across the blood vessels. Other effects include movement-induced effects when you have static field going as high as 2 Teslas or 3 Teslas. So this is typically the kind of field levels you would experience when you're directly under an MRI device. So there are numerous movement-induced effects such as vertigo, nausea, and also acute neurocognitive effects. For example, you have, distraction and also effects in your attention. So these are some of the neurocognitive effects which are experienced for movement-induced effects. Then you have the indirect effects. So for indirect effects, these are particularly for the coupling with active implanted medical devices. So this is, for example, why you have for pacemaker users, you have also for defibrillator users a special static field limit. So for magnetic fields, which is at 500 microteslas. This is because of the possible coupling of electromagnetic fields with active implanted medical devices. Then also you have for low frequency fields. So between 1 hertz to 10 megahertz, scientific studies show that low frequency field causes well-defined biological effects called electrostimulation. So some direct effects include stimulation of the central and peripheral nervous system and also the muscle tissues. And another effect is the induction of magnetic phosphines in the electrically excitable cells in the retina. Other indirect effects or probable effects includes association of electromagnetic fields, actually low frequency electromagnetic fields, with neurodegenerative disorders and cardiovascular disorders. However, the studies based on these different association between low frequency fields and these different disorders were considered inconclusive. Also, based on previous studies, the IARC from WHO categorized electromagnetic fields as category 2B, which signifies possibly carcinogenic to humans. So taking into account all these different effects, international bodies, so for example, you have ICNIRP, IEEE, these different bodies study all these different effects, and they use this to develop threshold or guidelines which define electrostimulation limits, which are used to perform assessments for avoiding overexposure to electromagnetic fields. Then also you have for high frequency fields. So exposure to high frequency electromagnetic field considered from 100 kilohertz to 300 gigahertz can lead to significant absorption of energy and also temperature increases. So between 100 kilohertz to 20 megahertz, the absorption occurs in the neck and the legs. Then when you go up to 300 megahertz, relative absorption may occur in the whole body. So this is, for example, the frequency range that you see where you have, for example, broadcasting applications, also other applications like medical applications where you have relative absorption that occurs in the whole body. But then also you have going up to 6 gigahertz. So in this range, significant local or non-uniform absorption occurs. And then the last range which you have is going above 6 gigahertz, where the absorption of energy primarily occurs at the body surface. So this means that the absorption at these frequencies above 6 gigahertz is superficial. However, it can lead to heating within the dermis, and the vascular network can transport this heat deep within the body, leading to an increased body core temperature beyond 1 degree Celsius, which is why these fields at high frequencies going above 6 gigahertz must also be measured. So standards define the limits for performing assessments for these kinds of fields. So this case, it takes into account the time average fields. So taking into account the time where this electromagnetic field is absorbed in the body to have any possible effects to the body. So these different effects are what we're going to look at in the upcoming slides. So to perform assessments for these two main interaction effects which we've talked about, so low frequency fields and also high frequency fields, there are different methods that apply when doing the measurements. For the first effect, which is the non-thermal effect, the weighted peak method or FFT analysis are used as defined by standards. But most standards recommend using the weighted peak method, especially in complex multi-frequency, low frequency environments. This is because using this weighted peak method, it takes into account not just only the amplitude of the signal, but it also takes into account the phase of the spectral components of the signal, thereby avoiding overestimation of the exposure index. Then for the case of thermal effect, time average RMS measurements are required using either broadband or frequency selective devices. So the standards define exposure limits which are based on the time average RMS value, which needs to be performed during a period of time. Sometimes it could be 6 minutes or 30 minutes, depending on the standard. And then assessment is done over this period of time, where these results are averaged over this period to give you the value which is compared with the standard limits. So between these two effects, non-thermal and thermal effects, there's an overlapped region. So this overlap region is between 100 kilohertz to 10 megahertz, where assessment has to be performed for both non-thermal effects and thermal effects. So we're going to take a look at some applications where these two different effects may be relevant for performing assessments. Okay, now let's take a look at some standards and guidelines. In electromagnetic field assessment, there are different standards from national and international bodies, which include emission standards, which specify procedures and also methods for limiting electromagnetic field emissions from devices and work environments. So these particular standards are the ones we refer to when we want to perform assessments in different sectors. So for example, in railway application, there are standards that define the procedures and the methods and also the measurement instruments to use for performing the assessment. So these kinds of standards, also called product standards, are the ones that define the necessary procedures and requirements for performing assessments in different industries. Whereas you have the second types of standards, which are called the exposure standards. So the exposure standards provide electromagnetic field exposure limits to avoid overexposure of humans to electromagnetic fields. Some examples of these EMF limits include the FCC maximum permissible exposure limit, also the IEEE exposure reference levels, the EU directive action levels, and also many more reference levels, which we're going to take a look at in the next slides. So these exposure limits are defined for two main categories of people. The first category is occupational limits. So this refers to people working near electromagnetic sources under a controlled environment with no prior health conditions and also are particularly trained on EMF risk. So these are, for example, the category of people who know about electromagnetic field and also they are aware of the exposure levels, they're aware of health and safety programs in order to avoid overexposure to electromagnetic fields. But then you have the next category, which is the general public exposure. So when you talk about the general public exposure, we're talking about individuals of all ages, different health conditions, and also you have vulnerable groups in this particular category. So these limits for public exposure are usually more restrictive than the occupational exposure because they take into account an extra safety factor to also take into account these different categories of people. So let's take a look at some of these different exposure limits defined by different standards. So first of all, there's the most used exposure limits, which is used globally, and it's the EMF reference levels. So most manufacturers selling internationally have to comply with this standard. It's also the standard that is adapted by many countries. So for example, you have this standard adapted by ARPANSA, which is used in Australia and New Zealand. This standard is also the one used in most Commonwealth countries. It's also the same standard which is adapted by the European Union. So it's the standard that is used in many other countries. So there are guidelines which are defined from the EMF, which are from 1998, 2010, and also 2020. So the 98 limits are still in use. For example, they're used in the automotive sector. So for example, if you're doing measurements in automotive applications, they would require you to perform assessments using the EMF 98 and also the 2010 limits. But also you have the 2010 limits and the 2020 limits, which replaces these 1999, 1998 limits, which for the 2010 limit is for low frequency range, so going up to 10 megahertz, whereas for the 2020 guideline, it goes from 100 kilohertz to 300 gigahertz. So it covers these ranges that are defined by the 1998 guidelines. So when you compare the 98 guidelines with the 2020 guidelines, some changes are seen. For example, you can see in the threshold values going up to 30 megahertz, and also the averaging time for performing the assessments for high frequency fields, which changes from 6 minutes to 30 minutes. In the case of European applications, for example, when performing assessments in Europe, these exposure limits are the recommendation 1999 for general public exposure assessment, and also for occupational exposure, which is a directive that was established in 2013. So this means occupational safety in the workplace must be observed for electromagnetic fields. So this law has been adopted by all EU members as of 2016, and also the directive is used in the UK as SEMFAL limit, which also is used for occupational safety. The directive states that employers must assess all risks for workers by measurement or calculation of electromagnetic field levels. And in the case of overexposure, action plans must be taken to protect these workers. For example, marking restriction zones to avoid overexposure to these electromagnetic fields, or for example, using protective devices to be able to ensure safety from these kinds of electromagnetic fields. Then, in the case of North America, there are different limits which are used. For example, you have the IEEE C95-1 limits, which is the exposure reference levels, and also the FCC maximum permissible exposure limits, which are used in the US. So the IEEE exposure reference level cover both electrostimulation effects, so talking about 1 hertz going up to 5 megahertz. And then for thermal effects, it goes from 100 kilohertz to 300 gigahertz. Whereas for the case of FCC limits, FCC standards cover thermal effects. So it takes into account going from 300 kilohertz going up to 100 gigahertz. And the averaging time is 6 minutes for controlled environment. So when you refer to controlled environment, you mean the area where occupational safety is considered. So for example, EMF workers, as we talked about in the different categories of workers. Then also you have the uncontrolled environment, which refers to the general public. So this general public, the averaging time is 30 minutes. This means that doing the measurements for occupational safety or controlled environments, you need to do the measurement over a 6 minutes period and do the averaging over the 6 minutes period. Whereas for the case of the general public, it has to be done over 30 minutes, average over this 30 minutes period. And then the time average result from this measurement is compared with the maximum permissible exposure limits. Then also you have the safety code 6 standard, which is used in Canada. So these safety code 6 reference levels cover a range from 3 kilohertz going up to 300 gigahertz. It also covers for nerve stimulation effects and also for thermal effects. So now let's take a look at the comparison between these RF limits, which we've looked at in the previous slides. So these different standards here, we have a comparison of the reference levels for general public and also for occupational exposure. So as we can see on this slide here, it's first of all the lowest limit and also the highest limits for the different standards and also the averaging time. So you can see from this graph here, the green line represents the safety code 6 limit. So the safety code 6 limit shows to be the most restrictive among the 4 standards which we're comparing in these slides. So when you compare the safety code 6 limit, it goes as low as 22 volts per meter as the lowest limit. And also for occupational levels as low as 49.33 volts per meter in comparison to the 61 or 61.4 volts per meter for the other standards, or the 28 or 27.5 volts per meter for the IEEE, the ECNIRP, or the FCC standard. And then also you have different emission standards. So as I talked about before, these product standards are the standards which are used for different applications. So electromagnetic field assessment is required in every industry where there's possible exposure to either electric or magnetic field. So this is why numerous organizations develop standards to guide the procedures in these different applications. So telling you how to carry out the measurements, the locations where you can find the maximum levels, and also the heights and the distances where these instruments, for example, the SMP3 device, has to be placed to perform these assessments. So these organizations include the IEC, which is the International Electrotechnical Commission, the International Telecommunications Union, ITU, also the IEEE. That's for the international case. And then for regional standards, you have CENELEC, which is used in Europe. You have also the GB standards, which are used in China. And then you also have the BSI standards, which are used in the UK. So all these different standards define the procedures in different applications. So here is an example, a list of different applications, and also the standards corresponding to these different applications and their frequency range. So for example, you have low frequency standards like automotive sector, welding application, also energy applications and railway sector. But also you have particular applications which also require you to do measurements for low frequency and also for high frequency. Then you have particular applications which are meant for high frequency applications, for example, in broadcasting, in telecommunications. So we're going to take a look at all of these different applications in the later slides. All right, now let's take a look at the electromagnetic measurement solutions to cover these different applications. So when we talk about electromagnetic field measurement solutions, there are different types of solutions to perform assessments. It depends, for example, on the nature of the assessment which is done. So you have personal safety where you need, for example, personal monitors. You have also large-scale applications where you need to perform area monitoring. But also you have spot measurements where you need to perform, for example, in situ measurements on site. You need to perform safety assessments in different environments where you require a wide range of probes to be able to use to cover all these different applications. So this is where the SMP3 meter comes in. So it's a complete EMF measurement solution which covers from DC fields going up to 90 gigahertz, and it's a portable EMF meter. So this portable EMF meter is a 3-in-1 instrument which allows you to be able to do DC field measurements. It allows you also to do spectrum analysis and weighted peak method going up to 10 megahertz. It also allows you to do broadband measurements going up to 90 gigahertz. In addition, it's compatible with all the field probes from WaveControl. So it allows you to be able to do different methods of assessment, but also covering a wide frequency range. It also allows you to have automatic probe detection. So you just need to connect the probe and it automatically detects the probe which you need to use. So you don't need to switch on and off the device to be able to detect the probe. It automatically detects it. It has also numerous other features. For example, it allows you to easily comply with standards. So it has a list of standard selections which you can use to configure the measurement settings for you. So in the previous slide, I talked about averaging times for exposure standards, where you need to know, for example, is it 6 minutes or is it 30 minutes? So what this device does for you is it allows you to be able to select the limit or select the standard, and then it predefines the limit and also the measurement settings and the averaging time for you to be able to perform the assessment. Then also it allows you to be able to connect the device via USB-C cable or fiber optic cable to be able to do live measurements. It also allows you to do weighted peak method going up to 10 megahertz to be able to have a direct comparison with the standard limit to have a direct weighted percentage with respect to the limit. You also have GPS integrated with the device. So for example, you do a measurement, you can have the GPS information for all the measurement samples which are taken. Then also the device is firmware upgradable. So for example, if there's a new standard, if there is a new limit which has been included, if there are also new features, maybe the device has also been improved, all these are done via firmware. So all you need to do is download the new firmware and then update it to your device. So it's an easy step which you can do to be able to have your device up to date. So all these are different things which are provided. Also, the probes which are delivered with these SMP3 meters are delivered with accredited calibrations. So you know that the instrument is certified to be able to do your assessments in different applications. Here you have a list of different field probes which are compatible with the SMP3 meter to cover different applications. For example, for DC field measurements, you want to do measurements in MRI devices, in railway applications, in some energy applications, in also different applications that require you to do static field measurements. You have the WPH DC probe to cover these kinds of applications. Then also for low frequency environments, which expands into numerous applications, residential applications like household appliances. You also have automotive sector, you have railway sector to perform assessments for occupational safety and also for the general public safety in railway sector and also in energy applications. So these probes called the WP series probes, which includes the WP50, the WP400 series and the WP10M, allows you to be able to do low frequency measurements up to 10 megahertz. Then for high frequency applications, you have for electric field, the WPF probes, which go from 100 kilohertz to 90 gigahertz with different frequency ranges, which you can select to cover different applications. In addition, you also have the magnetic field probes, the WPH probes, which go up to 1 gigahertz. So let's take a look at some of the features of this SMP device. So here's a list of different features which comes with all the probes. So these are the features which you can see with any probe you use. For example, it allows you to be able to do an all-in-one measurement. So for example, you do different measurements using this device, doing static field measurements, broadband measurements, FFT measurements, and also weighted peak method. It allows you to also have automatic probe recognition. You also have the double screen layout. So for example, on the screen, you have double values. So it gives you all the information you need on a glance. So for example, here you have the RMS value and the peak value. So you can see, for example, what's the weighted RMS value, but also what's the weighted peak value. You also have X, Y, and Z axis, the maximum, average, and minimum value. So all this information are giving you on screen. You also have the graph, so you can see the evolution of the field levels, and also in FFT to be able to see at what frequency you have the maximum levels. Then also you have a long list of limits to select from. So you have a wide range of limits to select for static field probes, for low frequency probes, and also for high frequency probes. It also gives you probe calibration warning. So these probes are recommended to be recalibrated every 24 months. So within these 24 months, these probe calibration warning are set for you. So once you're approaching the end of this calibration period, the 24 months, it gives you a warning indicating that the calibration is about to expire. And also when it's expired, it also gives you a calibration warning indicating it has expired. Then also you have spatial averaging mode to be able to do spatial averaging in different applications. You have also measurement scheduling, so you can allow the device and set a particular time when you want the device to come on its own, start the measurement and do the measurement for a period of time, and then stop the measurement and shut down by itself. So it allows you to be able to automatically configure the time to start the measurement. You also have multiple language options, so you have different options of languages to select from. Then for the low frequency probes, you have the WPH DC probe and the WP series probes. So these probes allow you to do static field measurements, broadband and FFT measurements, as I talked about before, but it also allows you to do single frequency logging. So with the case of frequency analysis, you can do the measurements up to 10 megahertz using the WP10M probe. It also allows you to have different span selections to have different resolutions in the FFT. So for example, you can go as low as 0.1 hertz. So going from one frequency to the next frequency in a very low resolution at 0.1 hertz, but also as high as 25 hertz. So it gives you the possibility to be able to see the frequencies at different points and also to be able to see where you have the maximum level and also the points where you have the lowest levels. Then also you have real-time comparison with the limits using the weighted peak method going up to 10 megahertz. Then also for the WP series probes, they allow you to do electric and magnetic field measurements. So you can switch from one or the other. Some applications require you to do both electric and magnetic fields. Some require you to do only magnetic field. So this probe allows you to be able to get the opportunity to do both kinds of measurements using just one single probe. Then also you have different functions, for example, the plot function, the bandwidth selection, where you can select different bandwidths to meet different applications. So for example, railway requires you to measure up to 20 kilohertz. You have the 20 kilohertz bandwidth. You also have 100 kilohertz. You have 400 kilohertz for household appliances, automotive applications, 5 megahertz for the IEEE low frequency assessment, 10 megahertz for ICNIRP, APANSA limit, safety code 6, all these different standards. You have different selections to be able to correctly configure the frequency range to measure within the specified ranges as given in the standards. Then also you have the high frequency capability. So it allows you to be able to do broadband RMS measurements. You also have a quick menu setup to be able to predefine the measurement settings for you. So as I talked about before, you can select the standard and it predefines the settings for you. For example, the averaging time, also the samples which are taken, all this information are predefined for you. Then also it allows you to be able to also define your own configurations. You also have the max fast RMS when you're using the fast probes. So with the WPF probes, the WPF 1840 and 60 gigahertz probe, they have the fast versions, which allow you to have an integration time of 4 milliseconds to be able to perform assessments for very short signals seen in radar applications and RFID systems. Then also the SMP is delivered with a PC software called the SMP software. So this SMP software allows you to be able to remotely control the units and also to be able to do live measurements. It also allows you to easily display the measurement data, the parameters, the applied limits. It also allows you to export the data from the SMP device to an Excel format report. So you have in the Excel format report, the logo, you have also the configurations, information about the device, which was used to do the measurements, GPS information, all the data from your measurements, and also all the screenshots which were taken during the measurements. Here's an example of the live measurement tab. So you can do the measurements from your computer using the fiber optic cable, for example, at a distance of 10 meters, 45 meters, and also set the device at that long distance and being able to do the measurements from your PC. So it gives you the possibility to be able to do EMF assessments and complying to standards with all these different features. Okay, now let's take a look at some of the industry trends. So we're going to look at some of the applications and the sectors where the SMP3 meter can be used. So the first example is the low frequency applications in energy sector where assessment is done for electromagnetic fields at 50 or 60 hertz and its harmonics. In areas, for example, with high voltage power lines, cables, so underground cables, and substations and other power installations. So the standard for this particular application is the IEC 62110 standard. It defines some fundamental procedures which has to be followed depending on the nature of the field. So for example, whether you need to perform the assessments for a single point, 3 points, or 5 points, if it's a uniform field, a non-uniform field, or underground sources. Then also the compliance with this standard requires you to use an instrument which complies with the IEC 617861 standard, which the WP10M, WP400, and the WP50 probes with the SMP3 meter complies with these standards. Then also you have the railway sector. So the railway application is also a very interesting application for using the SMP3 meter. The SMP3 meter allows you to be able to do complete assessments of EMF in the railway sector, going from DC fields going up to 20 kilohertz, as this is the frequency range which is specified in the standard, talking about the frequency range where you can find fields coming from railway infrastructure, the rolling stock, so referring to the train wagon, the traction systems, the rail routes, and also the platforms. So all these different sources generate fields going between DC fields up to 20 kilohertz. There are some areas where you can also find, for example, communication devices, which also need RF assessments. But for the railway sector in particular, the frequency range is DC to 20 kilohertz. So what does the SMP3 meter do for you in this case? The SMP3 meter allows you to be able to select the bandwidth going up to 20 kilohertz, where you can perform assessments for DC fields, for DC fields using the WPHDC probe, but then going up to 20 kilohertz using the WP400 or the WP10M probe using the bandwidth selection at 20 kilohertz. So it allows you to specifically tailor the solution to this particular application. Then also you have household appliances. So at home, we're exposed to electromagnetic fields from different household appliances, and this household appliance EMF exposure is covered by the standard, which is referred to as the 62233 standard. So this covers a frequency range from 10 hertz to 400 kilohertz for all types of household appliances and induction hubs, which are found within this standard scope. So it defines the procedures for performing assessments for human exposure to electromagnetic fields near this appliance. So the distance to do the measurements is as low as 0 centimeters, so meaning using the probe to touch these household appliances, for example, for really small household appliances. But also you have larger size appliances like refrigerators, electric ovens, washing machines. So all these different types of appliances require you to perform assessments at the top and the front at a distance of 30 centimeters to be able to determine the EMF levels or the maximum levels which are generated from these particular household appliances. So this goes up to 400 kilohertz, and also you can use the bandwidth selection at 400 kilohertz to do the assessment going up to this frequency range. Then also automotive sector, particularly electric vehicle manufacturing, is a growing sector with new requirements for low frequency magnetic fields measurements. So this is talking about assessment coming from the vehicle itself. So manufacturers of electric vehicles are required to perform assessments for inside, outside of the vehicles, and also the components which must be assessed to ensure human safety. So many international and manufacturer standards now exist to ensure EMF safety for this particular range going up to 400 kilohertz. Also, it's interesting to take into account the workers which also are involved in the manufacturing process of these vehicles. So it's important to perform assessments for these kinds of workers to ensure they are protected from overexposure to electromagnetic fields. Because, for example, some of these workers could include welders, which are involved in the manufacturing process, so the building of the car. Also, you have, for example, different aspects which deals with the different electric and electronic components which are installed in this car. So all these different components must be assessed, taking into account different operational modes, and also using an instrument that complies with the IEC 617861 standard, which the SMP3 meter and the WP400 or the WP10M probe complies with. The next application is also welding application. So evaluation of low frequency magnetic fields up to 10 megahertz is required by the IEC standard, as there is a presence of very high currents which could lead to significant exposure to magnetic fields. So a portable instrument like the SMP3 is required to measure the welder's head, the trunk, the limb exposure during active welding operations. So it's important to take into account the operation, the welding operation, and also take into account the distance of the welder from the welding equipment before performing the assessment. So taking into account, for example, the different positions where you can have possible exposure, which, as I mentioned, includes the head, the trunk, and the limb, using the limits which correspond to these different body tissues. So, for example, in the case of performing assessments for the head and the trunk, the whole body limit is used. Whereas for the case of performing assessments for the limb, for example, for the hand or for the legs, then you need to use the limb limits. So one advantage also you have with using this meter is it allows you to be able to select the limit, the whole body exposure limits, but also the limb limits to perform assessments in applications like welding. Then also in medical applications, there presence of low and high frequency fields from sources like MRI devices, diathermy, electrosurgery, and also different kinds of medical appliances. So the procedures for assessing electromagnetic fields in the medical sector is covered by the IEC 60601 standard. So this standard has numerous parts, which talks about different types of equipment which needs to be assessed. Also, a very important application is work safety, particularly industrial work safety, which the criteria requires you to perform this assessment in every workplace. So EMF safety is an example of an industrial work safety practice which has to be done. International standards and laws require assessing low and high frequency electromagnetic field exposure. So this is required in every industry where there's possible exposure to electromagnetic field, going up to 5 or 10 megahertz for low frequency fields and going as high as 60, 90 gigahertz for high frequency fields. The standard also specifies up to 300 gigahertz, depending on the application. So you have different applications which this assessment needs to be done. So it's important to ensure safety covering the frequency range which the equipment in these different industries cover. So for example, for low frequency probes, it covers up to 10 megahertz, so covering the entire frequency range as specified by international standard using the WP10M probe, but also going up to 90 gigahertz, as I mentioned, using the SMP3 meter. You also have different applications like semiconductor application, induction heating, RFID systems, AM radios, which require you to perform assessments for both non-thermal effects and also thermal effects, because they go within this overlapped region, which we talked about before. So that's 100 kilohertz up to 10 megahertz. So this particular range needs to be covered for both kinds of assessments. Also, one of the most relevant applications in high frequency is radio communication, so telecommunications, and also even broadcasting applications, for example, AM broadcasting and also FM broadcasting. All these different kinds of application needs to be taken into account. So an example of a standard that talks about telecommunications is IEC 62232 standard, which covers these radio communication sites, where there's the standard presents different methods for performing assessments using broadband evaluation or frequency selective methods for performing this assessment, with both of them having their advantages and disadvantages. For example, broadband device being fast, easy to use. Then also, for example, for frequency selective, it gives you information about the frequency information. So all these different devices have, or different evaluation methods have their advantages and disadvantages. But for example, for performing assessment, the standard recommends you to start with broadband assessment. And then if you comply with the standard limits, then you know that you're compliant with the standard limit. It also allows you to be able to do different spot measurements to also save time in performing your EMF assessment. It also takes into account all the sources which you're exposed to. So for example, imagine you have 4 different sources. It takes into account the fields coming from all these 4 different sources and gives you one exposure index, which you know that you can compare with the standard limits to see if you are below or above the standard. So this is also one very interesting application using the SMP meter, because for example, using the SMP meter, you can perform spot measurements. So in situ measurements, you go on site, or for example, let's say for tower climbers, you want to perform assessments, you can go and do measurements at different spots and also perform assessment at these different spots using spatial averaging, for example, to get the measurements at different points, different heights, and then get a cumulative average of all these different points. Then also in telecommunications application, here's an example of 5G measurements using a broadband device. So in this case, the SMP3 meter and a WPF probe. So the WPF probes have different selections. They cover the FR1 and the FR2 bands for 5G applications, so allowing you to be able to cover these kinds of application. So here in this example, what the operator did was using a mobile device to draw traffic towards the SMP device to measure the maximum field levels. So this is also one of the strategies for measuring 5G applications as defined by the standards. Then also one very interesting application in high frequency is also pulse signals, which are present in radar systems, where the illumination occurs in a small fraction of time, typically few milliseconds for scanning radars. So RF safety and measurements of scanning radar output power are some important aspects of EMF measurements in defense sectors and also in commercial aviation. So for example, you have these commercial radars which are used at airports, so covering around 2.6 to 2.8 gigahertz. So all of these different ranges of frequencies can be covered using the SMP meter. But also, when you talk about these short signals that are seen in scanning radars, you have a fast integration time for the fast probes at 4 milliseconds, which allow you to be able to measure the radar output. So it gives you the maximum RMS value. So what we call the max fast RMS. So this max fast RMS is the maximum of all the 4 milliseconds which has been done in the sampling period, which the device gives you as a refresh on the screen, where you have the maximum level indicated on screen. So in this case here, it allows you to be able to capture these short signals which are measured from these scanning radars. Okay, now let's take a look at how to perform the assessments with the SMP3 meter. So to perform assessments with the SMP meter is very simple. It's just first to connect the probe And then you configure the measurement settings like durations, the samples, or you can just, for example, select the standard and it automatically defines these settings for you. Then the next step would be to configure the dynamic settings, for example, selecting the mode, limits, or units. And then once this is done, you just need to place the SMP meter at the correct distance, the correct height, as specified by your standard, or depending on the application which you want to measure. So taking into account the distance of the operator from the machine, which has to be measured. And then once you set the device at that point, just press the lock button to start the measurement and then save the measurement. So these measurements would be saved to your device, and then you can access these measurement results from the measurement log. So the measurement log gives you information about all the measurements which has been done. You have also the list of the samples which were taken, the screenshots, all of this information are given on the screen. Then also you can download the measurements using the SMP software. So you can download it and export it to an Excel format report, which you can use for further post-processing. Okay, now just to summarize what we've been looking at today. So WaveControl offers a multiple EMF solution using the SMP3 meter to be able to perform assessments for multiple applications and also to meet standard requirements. The SMP3 meter also allows you to, or allows the user to comply with low frequency ranges, and also, for example, the measurement methods which are specified by international standards. So going up to 10 megahertz for low frequency, but also performing weighted peak method and FFT analysis. Then for the case of high frequency fields, using the time average measurements as specified by standards to be able to give you a comparison to the exposure index based on the standard limits. Then also you have adjustable bandwidth for different applications. So you can tailor the applications by selecting the bandwidth selections in low frequency applications. Like in railway sector, you can select it to 20 kilohertz. In household appliances, you can set it to 400 kilohertz. If, for example, you're doing low frequency industrial applications, you can set it to 100 kilohertz. So you have the possibility of selecting all these different bandwidth selections to be able to do your measurements. Then also you have excellent measurement capabilities. For example, you have measurement scheduling features. You also have alarm features. You have different configurations which allow you to easily comply with standard limits. Then also you have a long list of limits to select from for static fields, for low frequency, and also for RF fields. Okay, so that's all for my presentation. So please feel free to ask your questions so we can go into the Q&A session.
John, really appreciate it. Really well done. I appreciate the details and the spread of topics that you covered today. Surprisingly, there's not a single question in the chat. I think that backs up what I just said of how well of a job you just did. However, would you be able to go back to the first 2 or 3 slides at the beginning of the webinar today? It sounded like your audio kind of cut out. I think you were just covering the range of equipment that WaveControl owns.
Okay. So just this one.
Yes. Yep. Exactly.
Okay. So this is the product line from WaveControl. So you have the portable EMF meter, which is the SMP3 meter. So it's the one we talked about today. So it's the one that allows you to be able to cover a wide frequency range going from DC fields up to 90 gigahertz. It's a portable EMF meter that allows you to be able to measure DC fields, DC magnetic fields. So for example, you want to cover MRI devices, you want to cover, for example, strong magnets that are seen in, for example, waste disposal. You want to also cover railway application. So this is the DC field probe, which could be used to perform this assessment. Then also you have low frequency probes, for example, the WP series probes, which goes up to 10 megahertz. You also have high frequency probes that go up to 90 gigahertz. Then you have, for personal safety applications, the personal monitors, which are called the WaveMon. So it's the low frequency one, which goes up to 400 kilohertz. You also have the high frequency one, which goes up to 60 gigahertz or 8 gigahertz, depending on the application or depending on the model which you select. It also goes up to 1 gigahertz for magnetic fields in both cases. Then for area monitors, so for continuous monitoring, larger scale applications in outdoor environments or in indoor environments, you have the MoniTM family, which goes for outdoor applications with the MoniTM. and then the MoneyTM lab, which is the one that is meant for labs. So for example, this is the one used in research labs. This is the one used, for example, in labs where they're doing a lot of testing, like telecommunications labs, also manufacturing centers, production plants. This is the one that is usually interesting for indoor monitoring. So it allows you to be able to, for example, mount it in different areas in the labs, and then also detect electromagnetic fields, so RF fields coming from different sources, and then giving you a warning. For example, you can have an audible and visible warning when you go above the threshold level, which is set on this device. So you can use it, for example, for leakage detection, but also for RF safety application. So it allows you to be able to diversify your applications using these different instruments.
Thank you, John. Could you please put up your contact information back up? We got some
Sure.
attendees that would love to be able to get in touch with you. In terms of conducting actual measurements, does the orientation of the probe matter when taking those measurements?
So they are isotropic probes, so you don't need to worry about the orientation. I mean, it takes it from all three axes. So you just need to place it, and it does the summation of the three different axes.
Great. Would you be able to cover briefly the WaveMon and the personal meters, and are those able to data log?
Yes. So the WaveMon also it has a large storage capacity, so you can store up to 1 million samples. So with the case of the WaveMon, it allows you to be able, it gives you a percentage with respect to the limit. So let's see if I can go to the yeah. So here you can see you have 10%, 25%, 50, 75, 100, 200%. So these are the levels which it is in comparison to the standard limits. It allows you to be able to switch from general public limits to occupational limits, and then it gives you the level in comparison to the standard limit. So for example, if you're at 10%, 25%, it gives you green LEDs. If you go above 25, like 50, 75%, it gives you orange LEDs. And then once you go to 100% or 200% and above, because it goes up to 1,000%. So it allows you to be able to measure from 0.5% to 1,000% of the standard limits. So what it does is that it gives you a vibration and a sound, and also the LED indicates when you've gone above the levels. So that's what the WaveMon does. It also saves these measurements to the WaveMon device. It also comes with a GPS. So you have information about the measurements, but also the GPS. So let's say, for example, you have tower climbers that want to, for example, mount this WaveMon device on, for example, a harness or just on their arm. So they can put it there, do the measurements, and then get the levels. And then once they see the levels, for example, if it gets a vibration, because you can set it to time average results, if it gets a vibration, then they know they need to step away from the EMF source. But also this information is all saved. So the field levels are all saved to the device. So you can later on, when you go back after like you've done the work for the day, you can go back, plug it to your PC, and then download the data, and then, for example, see at what time you had this particular level. It also has an altimeter. So let's say, for example, you're a tower climber. As you start from the ground point where you switch on the device, it gives you a reference of the height while climbing. So in this case, you can also compare, for example, the results and also the field levels, the exposure levels with the GPS information, and also with the altimeter information.
And with these wave controls, at least in our inventory, we have straps that you can connect to a worker. Are there also like belt clips? Is that possible, or is it simply just straps?
So here you have this cradle that allows you to be able to, for example, so the device comes with the armband. You have an armband which you can just, for example, attach it to your arm. But then also it comes with a non-elastic band, which allows you to be able to, for example, strap it to a harness. So it's just easy to also strap it to the harness. Actually, we have a YouTube video on our YouTube channel that shows you, for example, how to wear the elastic band and the non-elastic band. So you can take a look at it. You can also wear it on a belt. So you just pass your belt through this cradle, and it allows you to be able to place the wave mount on the belt. But you can use the elastic and the non-elastic band to, for example, mount it on different parts of the body.
Perfect. Well, John, I really appreciate you taking the time out today to teach me something along with all of our attendees. I think you did a really great job. As a reminder for everyone, we'll be sending out a certificate of attendance for today's webinar. The slide deck and the replay of the webinar will be posted on our training sites, training center, sorry. You can also find video demonstrations on how to use equipment, past webinars, pretty much anything you need to know to get you familiar with new equipment, all there for you. If you need any questions about equipment, you can call Rayco Rents. Our number is 866-RENT-EHS or 866-736-8347. You can also reach us by email, rentsconfirmation@raycorents.com. For now, it's going to wrap up our webinar for today.